not here yet, but we're going to start early because we won't have enough time. We have very short periods today. So, okay, so the homework is in the book tonight. You guys are responsible for it. The limit definition of the derivative, you should know that by now. I'm not going to even write it. Going over the homework, you had to use deriv, enter the function, comma x, comma the value. On the worksheet, we have the first one, 1/4, b, -38, c, 100, d, 1, and e, 0. These are the values that the calculator gave us when you put in deriv, comma x, comma the value that they gave you. Now, not all of these answers are right, so we were supposed to go through and look at the graph at that x value. And as long as at that x value was continuous, no corners, cusp, or vertical tangents, you can believe the calculator. So, A was fine, that's true. Same with B. But C, if you look at y equals the cube root of x at 0, you'll see there's a vertical tangent there. So you don't trust the value that the calculator gave you. Tan x is fine at pi. You might be thinking pi over 2, but it was at pi. And E, there is a corner at x equals 3, so do not believe that the derivative of this function at 3 is 0. That's false. Moving on to the second part, they wanted you to graph the derivative and see if you could guess what it is. So I have it showing here what you do to graph the derivative. So to graph the derivative of negative cosine x, I put in y2, and deriv negative cosine x, comma x, comma x. And when you look at the graph, hopefully you can identify it as sine x. I'm just recording early, so we have time. E, you had to graph the derivative of sine x. When it shows up, hopefully you recognize that that's the cosine x, so the derivative of sine x is cosine x. C, you graph the derivative and deriv 0.25 x to the 4th, comma x, comma x, and you get what looks like x cubed, and it is x cubed. And finally, D, when you graph the derivative of that function, you get the absolute value of x. Oh, I had a few more. E, you graph the derivative. It's actually the tan function, tan x. And F, when you graph the derivative, that's 1 over x. Hi.
Just a reminder that we can video
So worth it. Okay. So today we want to find out the derivatives of the 6 trig functions. And sine and cosine take a little bit of work. The rest are easy. We just use the quotient rule. Now, in order to get the derivatives of sine and cosine, we need to know these 2 limits. One of the limits, we've actually seen this before. The limit of the sine of an angle over the angle. If the angle is getting really, really small, do you guys remember graphing that? Oh, you are here. Jess Thomas is here, people. Don't worry. Do you guys remember graphing sine x over x in radian mode earlier on in the year? Do you remember what this value was that the y's were approaching as the x's approached 0? 1. Okay. Now, there's a much more complicated way of showing that. It's called the sandwich theorem, but we're definitely not doing that. So that's one theorem. That's one limit we're going to need. The other limit, so we need to know that the limit of sine x over x, if x is approaching 0, is 1. The other important limit that we need today is the limit of 1 minus cosine of an angle t over t as t approaches 0 is 0. Now, I have the proof for this written down. I just want to see if you guys can just pick out how I could do all this. So we're looking for this original limit. What allows me to multiply by this? It's just 1, right? You're allowed to multiply by 1. Can you see what goes on? How do we go from this step to the step next to it? What do we actually do? Multiply, right? So far it's not too bad. And these are conjugates Now, do you guys remember what 1 minus cos squared of an angle equals? Sine squared. So that's all we did here. We substitute in the sine squared. So that's just the trig identity. Now, going from this step right here, you can't see where I'm pointing, to the one next to it, we just broke it up. So instead of leaving it sine squared t, that's sine t times sine t. So we just broke it up. And that's one of the great things about limits. You can find the limits of each factor separately. And now we know what the limit of sine t over t is if t is approaching 0, right? So this limit equals 1. And if t is approaching 0, what is the sine t of t approaching? T is 0. Do you guys know what the sine of 0 is? Sine of 0, think of your unit circle, the y-coordinate. 0. And then in the denominator, we have 1 plus the cosine of 0. What's the cosine of 0? And what is 0 over 2? 0. And again, don't worry too much about this. I just wanted to show you. So we need these two limits. And I'll show you why. Because when you want to know what the derivative of a new function is, you got to go back to that limit definition of the derivative. Oh, we're also going to need to know some trig identities. I'm just throwing it out there. Does anyone remember there are these sine of a sum? Anyone remember this one? What do you got? That is the sine of 2 theta is 2 sine theta cos theta. That's what you're thinking of, the sine of 2 theta. It has something to do, it's sine A cosine B plus, okay, sine A, wait, did I just change it? Sine B, sorry, cosine A. Good. That's a B over here. Now there's another one over here. You got to know. Cosine of A plus B. I mean, you always had these on a sheet, so you never really had to memorize them. Work? Okay, anyone remember that one? Thing. Yeah, just switch the order. Cosine A, cosine B, minus sine A, sine B. Now they're all familiar? Okay, well, yeah, a little more reference. Okay, so here's the thing. I'm going to show you how to get the derivatives of sine and cosine so you can just appreciate it. But the ones that you have to be able to show me that you know how to derive are the other 4 trig functions. Let's just do sine. So the first thing when you're trying to find the derivative of a new function is apply the limit definition of the derivative. I was going to say the name, but then I didn't. It's horrible. All right, but we spared you. So now we got to, so the sine of x plus h, how can we write that? Sine x cosine h, good, plus sine h cosine x, and we have the minus the sine x over h. See what we just did? We just applied that, the sign of a sum identity. Now, addition is commutative, so I just want these two guys to switch places. So let's just switch places. We have the limit as h approaches 0 of sine x cosine h minus sine x plus sine h cosine x over h. Now, I want to pull a sine x out of the first two terms. You see how there's a sine x factor? Okay. So we have the limit as h approaches 0. We've got sine x times the quantity cosine h minus 1. And then I have plus sine h cosine x over h. Now, I'm going to break this up into two fractions. Right now, the whole thing's over h. Limit as h approaches 0. I should have condensed a little bit. So it's going to be sine x times cosine of h minus 1 over h, two fractions, plus sine h cosine x over h. I took the one fraction. You know, we could put it back together. Now we're almost there. We're almost there. Because the great thing about limits is that you can take the limit of each term separately. Now, when you take the limit as h approaches 0, it doesn't affect anything with x's, okay? So what we're going to get when we take the limit of the first term is the sine of x times this limit. The limit of cosine h minus 1 over h as h approaches 0. That was 0. So times 0. Plus, the cosine x is not going to be affected. What would the sine of h over h, the limit of the sine of h over h, be as h approaches 0? 1. So this gives us a big conclusion that the derivative of sine x equals cosine x. Amazing. Get out. We can't believe it. I knew it would. Sometimes that's all the kids need. Now, the other basic proof works the exact same way. We just use the other identity. Should we do it or skip it? Skip it or do it? It's the same thing, but almost. If you go through all this to find the derivative using the limit definition of the derivative, cosine x, it turns out to be negative sine x. I'll put it on the video so you guys can watch it. You're not responsible to do it, but it's the same thing. You use the cosine of a sum with your limit definition. Okay, so blah-de-blah-de-blah, and we get negative sine x. All right, so let's just see what we got. The derivative of sine x, do you remember what we got? Cosine x. But the derivative of cosine x is negative sine x. You got those two? That's all you need. Because now any of the other 4 trig functions, we're going to get with the quotient rule. So since that's what you're responsible for, that's what we'll do here. So let's say we want to get the derivative of tan x. We have to know that tan x is sine x over cosine x. It's a quotient. So let's use quotient rule. How do we start to find the derivative of quotient? Where do we start? Below. So we write cosine of x d high. What's the derivative of sine x? Cosine x. So low d high less high sine x d low negative sine x. The derivative of cosine x is negative sine x. So the line down below, the denominator squared will go. Okay. You can either put the parentheses around the whole thing and do what I did, or just put the squared after cosine, because that's what that means. But you don't want to think you're taking the cosine of x squared. Look at that numerator, kids. Stare at it. Isn't it just 1? Yes, it is. Oh my gosh. Thank you, Pythagorean trig identity. That's just cosine squared x plus sine squared x, which is just 1. Could it get better than this? Do you guys know what 1 over cosine x equals? Secant x. So this is the same thing as saying 1 over the cosine of x squared, right? So the derivative of tan x is secant of x squared. And I'm just going to write it like this. I'm going to put the squared after the secant. But realize that means you're squaring the secant of x. When you have a trig function with an exponent there, you're squaring the trig function of the angle. So now we know the derivative of tan x is secant squared x. That's something you'd have to be able to show. All right? Let's do the next one. Derivative of cotan x. Cotan is cosine x over sine x. Are you serious? Oh, just get the letter first. All right. She was the one that cursed before. All right, so we want the derivative of cosine x over sine x. Let's start the quotient rule. Here we go. What are we writing? You tell me. Sine x. Negative sine x, because the derivative of cosine x is negative sine x. Minus cosine x. Cosine x. All over the sine of x squared. Now that numerator, that's negative sine squared x minus cos squared x. What does that equal? We know sine squared x plus cosine squared x is 1. You see that would be, if you pull a negative out, that's going to be a negative 1. So that's negative 1 over, yep, which is equal to negative cosecant squared x. We got another derivative. So the derivative of tan x was secant squared x. The derivative of cotan x was negative cosecant squared x. We got to do one more. I don't know if we'll fit 2, but we can do one more. We have to. All right, we want the derivative of secant x. Secant x, if you recall, is 1 over cosine x. Quotient rule. Here we go. Low is cosine x. And high, what's the derivative of 1? Okay. Less high minus 1 below. Good. Times negative sine x. All over cosine of x squared. What's that numerator? Sine x. So we have sine x over cosine of x squared. I can break that up into sine x over cosine x times 1 over cosine x. You see that we can do that? What's sine x over cosine x? Yeah. And 1 over cosine x? Secant x. We don't memorize it in this order. You know, it's commutative, doesn't matter, but it's, so we say the derivative of secant x is secant x tan x. The very last one, I'm just going to go right to the punchline for it because I want you to see. If you go through and you find the derivative of cosecant x by using the quotient rule, you wind up with, remember the derivative of secant x was secant x tan x? It turns out to be negative cosecant x cotan x. Now I want you to see it all together, and it's so you can appreciate the beauty of it all. But these are not hard to show. So let's see them all together because you have to memorize these. So what was the derivative of sine x? Cosine x. And the derivative of cosine x? And using the quotient rule, we can get the others. What was the derivative of tan x? Secant squared x. What about cotan? Negative cosecant squared x. The derivative of secant x? Secant x tan x. And the derivative of cosecant x? Negative cosecant x cotan x. What do you notice about the derivatives of all the trig functions that start with the letter C, all the they're all negative, right? Isn't that going to help us memorize? So if it's the trig function starts with the letter C, those are the ones that have derivatives that are negative. The other thing that I think is going to help you memorize, look at, if you can memorize the derivative of tan x as secant squared x, it's the same thing for the cotan. It's just with it's negative cosecant squared x. So for tan, the derivative is secant squared x. For the derivative of cotan x, it's negative cosecant squared x. Look at over here. The derivative of secant x is secant x tan x. Derivative of cosecant x is negative cosecant x cotan x. It's really, if you can memorize, well, everyone knows those two, and I'll show you something even quicker to memorize those. But if you can memorize these two, those two will come automatically. It's the same for the co-trig functions as it is for the regular trig. Now, what you're going to do is you're going to try a couple problems actually in the book tonight. And I went to the beginning of this. The big thing is that you memorize these. We're going to practice using them in the product rule and the quotient rule and all that. But they're just page 146, 1 to 9 odds. The answers to all the odds are in the back of the book. So you can check your answers. Yeah, that's just one. Yeah, it's like barely anything. And if you had trouble on last night's homework, I'll answer any questions on that tomorrow also. You guys are awesome. We did it. Bye. Bye.